Okay, guys, here we are at lesson 50 already. I want to go over this lesson with you today. We're going to be discussing polynomial equations, ordered pairs, and the Cartesian coordinate system, which you better know as the coordinate plane. And I'm going to start by just doing a quick little review on this blank sheet of paper right here for lesson 50. The reason I want to do that is I just want to make sure that these terms that we're using for polynomials become more solid. In our little review here, let's talk about what a polynomial is. We know that it has to take on the form as ax to the nth power, where a is any real number, and n is always a whole number. It can't be a negative. Remember, it has to be a positive whole number. This is called the polynomial form. Okay, we know that a polynomial, we can have a polynomial can be made up of one term or several terms. And here are some that you might want to look at. We could have a 2x to the third as a term. We could have x with no exponent. Well, we know that's 1. The exponent would be 1. Or we would have x, y, z could be a possibility as well. Now let's talk about what degree these terms actually are. How do we tell in a term what degree it is? Well, we take the highest exponent. In this case, this is a third degree term. This is a first degree term because the exponent would be a 1. And then the x by z has 3 exponents of 1. So this is also a third degree term. What about when we're talking about, this is the degree of a term. What about a degree of a polynomial? So let's write down a few of those. We would have, here's a possibility, x to the third plus xy plus m. We could have 2x plus 4y. We could have 2x. Now remember, the degree of a polynomial is the same degree as the degree of the highest term. So let's look at all 3 terms in this first one. We have 3 terms making up this polynomial. We notice that we have an exponent of 3 on the x, which looks to me like that is the term with the highest exponent, the highest degree term. So this is a third degree polynomial. I'll abbreviate that. How about this one? They both have an exponent of 1, so this is simply a first degree polynomial. And this one also has an exponent of 1, so this one is also a first degree polynomial. Now today, we're going to be looking at polynomial equations. Whenever you have polynomials that are connected by an equal sign, well, now you're looking at a polynomial equation. And how do I know? Let's take a look at one of these. Actually, I'm going to write down 3 just like I did up top here. We're going to decide what degree equation this polynomial equation is. So let's say we have x to the 4th minus 3x squared plus 2 equals 0. Let's have x, y, z plus y equals 4, and y equals 2x plus 4. And just like we mentioned up here, to find the degree of a polynomial, which happens to be the same degree as the degree of the highest term in your polynomial, the same is true of a polynomial equation. It's going to be the highest degree the highest degree term is what's going to determine the degree of your equation. So let's look at these 3. So what's the highest term? X to the 4th has the highest exponent. That is the highest degree term. So this is a 4th degree polynomial equation. I'm going to abbreviate that. How about this one? I have 1, 2, 3 exponents here of 1, which means we add those up, that is 3. That term is a 3 degree term, third degree term. So therefore, that's the highest degree term in my equation. So this is a third degree polynomial equation. How about this one? The highest degree on my y and my x are both 1, so this is a first degree polynomial equation. Okay, so you identify which term has the highest degree, and that determines the degree of your polynomial or your polynomial equation. Okay, so let's look at, I'm going to write down a polynomial equation, which is the same one you see written right up there, y equals 2x plus 4. We just wrote that right up here, and we're going to use that for a moment. Now, we know there are an infinite number of pairs of values for x and y that are solutions to any first degree equation when they're a polynomial equation, when there are two variables. So let's just say we have this. I want you to think about, you remember not long ago, or even in past years, we've had this little function machine that I've tried to draw out for you. Okay, and inside of it is 2x plus 4. We figure out an x value. Let's say we're going to assign x with the number 2. So the 2 is going to go inside here. It's going to jumble up with this equation inside there, or this expression, and it's going to spit out what y is equal to. So we could simply work this out over here, and we would get y equals 4 plus 4, y equals 8. So in this case, it would be spitting out an 8. Okay, how about if x was equal to -5? Let's use the same equation. We won't throw it in the function machine again, but I wanted you to recall that this is what we're doing here. When you think about substituting in x and figuring out y, it's like that function machine we used to talk about. So let's put a -5 in for x. Oops. We would get -10 plus 4, and y equals -6. Okay, so when x is 5, y is 6. And in this case, when x was 2, y is 8. Okay? Now I want to express a couple things about this. When I assign, or when you see an x assigned with a value, x is known as your, this is very important, this is your independent variable. The reason it's independent is because I can put anything in for x that I want. X doesn't rely on what y is going to be. However, y relies upon what x is going to be. So x is your dependent variable. And actually, the function machine kind of helps you to see that. I can throw anything in for x, but y is calculated and figured based upon what you put in for x. So y waits to see what x is going to be, and then y knows what it's going to be. So y depends on x. But x is an independent variable, whereas y is a dependent variable. Okay? Now, another thing, let me get one more sheet of paper here. We want to talk about ordered pairs. Because what we did learn when we used that function machine, or whenever we're given some polynomial equation and we put a value in for x to determine what y is, we can take that x value and that y value and make what's called an ordered pair. And keep in mind that there are all kinds, and I made this statement just a few minutes ago, but there are all kinds of variables that I could throw in for x, and I would get another y value, right? A lot of different solutions can make this equation true. And we know that a couple of them are 2 and 8. And we also knew by putting in the -5, we now have another set of ordered pairs. I could continue to throw all kinds of x values in there and get all kinds of y values. And remember, we use those to plot a line. Okay? An ordered pair has an x value and it has a y value. Sometimes people, and I've never seen this, but Saxon makes mention of it, so I'm going to mention it in case we should ever see it again. You can name these variables whatever you want, but the understanding must always be that the first variable is x and the second variable is y. So this is your independent variable, and this is your dependent variable. And when you graph them on a coordinate plane, they're going to be in that order as well. I'm going to erase that though, because I don't really think that we need to hang on to that. I believe we're always going to see X and Y. Okay, but I wanted to point out that the variables could vary, but you need to make sure you understand that the first variable is independent and the second variable is dependent when you're listing your ordered pairs. Okay, now let's move on to the next part of the lesson, which is the Cartesian coordinate system. Okay, now we have already discussed things like here's a number line, here's another number line, and we could plot x equals 4 on one of them. Let's say here's 4, here's 5, 3, 2, 1. X equals 4, we would plot it like so. We might have to plot something that looks like this. X is greater than or equal to -2, and we know how to graph that as well. We would have a closed circle at -2, and we would state that X is greater than or equal to that by showing our line continuing in that direction. Okay, these are called, by the way, one variable graphical forms. Okay? Or form, I should say. Not necessarily forms, but form. That's what they call this. Okay, one variable because we only have X to deal with. But now we want to look at two variables, and two variables introduces another type of graph, which you're very familiar with. So this would be a two-variable graph, or graphical form, but I'll just call it a graph. And we know this as, actually, this lesson introduces it as the Cartesian, which was named after some French philosopher who named this system coordinate system. That's one of the names for it. It's also called just the coordinate system, but we really call it, mostly, we might call it a graph, but it really would be either a coordinate plane or maybe you could call it a coordinate grid. Okay, so really I guess there's four names. So what does that look like? Well, we know it's going to be like one of these where we have two axes because we have two variables. So we have to place on our coordinate plane something that represents both of those variables. Okay, and we know that we can utilize our set of coordinate points to place those onto our coordinate plane. Now let's just identify just a few things. The center of this thing is called the origin. And actually this might be a good time to go down to our notes and fill in some of these blanks. Okay, right here where it says recall the Cartesian coordinate system is a rectangular coordinate system that consists of, and I'm going to change my color to a different color, the x-axis, which is the horizontal, which goes left to right, and the y-axis, which is vertical, up and down. Where the two axes intersect is known as the origin. Okay, and we know that to graph an ordered pair on a coordinate system, we use the x value to determine the distance that goes from left to right, and the y value to determine the distance that goes up and down. I want to discuss very quickly with you down here or up here, where was it? Right here. There are quadrants. Quadrants means four. Quad means four. So a quadrant means that we have four of these on this coordinate plane. And interestingly enough, we don't count in the order you would think. We go counterclockwise. We start with quadrant 1 up in the upper right-hand corner, quadrant 2, quadrant 3, and quadrant 4. If you think about quadrant 1, all of your coordinate points that are going to be up in this region or this quadrant of your coordinate plane will be positive. Your x and your y will both be positive. Why? Because on my x-axis, I'm going to be traveling this direction, which is a positive direction, and on my y value, I'm going to be traveling up, which is also positive. So all of my points that get plotted into that quadrant have both positive numbers within the set. Okay, so that's interesting. And then you think about down here, quadrant 3, they will both be negative, right? Because I'm always going to be going this way on the x-axis and down this way on the x-axis. Up in quadrant 2, you're going to have a negative and a positive. And in quadrant 4, you're going to have a positive and a negative. And that's just the way they are all going to roll. Okay, so let's go on back down here. We're going to do a little practicing here on how to plot our coordinate points onto our coordinate plane. So notice in this one right here, you can see there's one that's plotted for you. And I believe you guys have had lots of practice on this, but I will not be remiss in not teaching it to you. So we will go ahead and just discuss it quickly. So here's the point found at 2, 5 is the coordinate point's address. And the coordinates are 2 and 5, basically. So since 2 is the x value and 5 is the y value, we go to the x-axis and we move in a positive direction 2 steps. And from that point, we move up 5 points because that's along the y-axis. Y goes up or down, and x goes left or right. So there's the point that lives at 2, 5. Now we're going to try some of these. Let's look at number 1 here. Each letter. What is number 1? Oh, okay. Number 1, I'm sorry. Okay, so number 1, this is a little confusing to me. It goes over here. We're going to plot and label these points that you see in number 1. A is 2, -3, B is -4, 3, and so on. So how do we do this? And you may already know, and you can try them without me. You can pause the video. But we're going to go ahead and plot 2, -3. So 2, -3. I'm going to go over 2 on my x-axis and down 3, did I say? Down 3. So 2, -3 lives right there. And we're going to go ahead and put the name A right there. I'm going to choose a different color. For B, -4, 3. -4, 3 is here. That is B. C is 1, 5, which is here. And D is 0, -4, which is right here. Okay, one of the habits I want you to get into, and it's a good habit, is starting to label what you have placed there. And I actually didn't need to put 1, 5 here because he actually has a name. What is that one? A, B, C. Okay, there's C. If it doesn't have a letter with it, though, you do need to place the address along with it. So for C, if it wasn't labeled here as C and it just gave you the coordinate points, you would just, or the coordinate pair, you would just put 1, 5 there. All right, so let's look at number 2. We're going to write the ordered pair that represents each letter on the grid on the left. So let's look at A. I'm going to blow it up a little bit here. A is right up here. So I'm going to see how far to the right did I go on the x-axis to get to the line where A is living. So starting at the origin right here, I'm going to move over to here. That is 6. So I know my x value in my coordinate pair, or my ordered pair, is going to be 6. And then to go up, I'm going to go up this many, up to 8. And actually, you can see that right over here. So that address is 6, 8. How about B? B is at, we're going to do the x first. We go over to -6, and it goes up 2. And then finally, C is over 4 and down -4. Okay? And that's really all there is to it. So let's do the practice one together. That can be found on page 204. We're going to plot 2 points onto this graph, and you're going to label their address, meaning you're going to write the ordered pair right beside the dot. Please try to be very neat about this, making sure that you're labeling close to your point on your graph. So the first one is A. We're going to label -6, -7. So -6, we're going to follow the axis to the left because remember, x goes left and right. And then we're going to go down 7 because it's a -7. So we're going to go down to -7 right there. And we're going to write in what the ordered pair that took us to that location on our coordinate plane, -6, -7. The next one is 4, -5. So we'll find the x-axis and we'll trail to the right 4 because 4 is positive. And remember, the x value travels left or right. So we go over to 4, and y is -5, so we're going to go down to -5 right there. And that point is 4, -5. And that is all there is to it. So you can go ahead and get started on the Lesson 50 problems once you have your notes filled in. I hope